of a moving object using the momentum principle in GlowScript with the actual motion I measured in Tracker based off of a video. The goal was to see how well the computational model lined up with real-world data. So the main principles that I used and the model setup was the momentum principle, which was able to give us the velocity update formula as well as the position update formula. And so the mass of the system, so the mass of the expo marker, which is what we used to roll, was 0.01 kilograms. And we assumed the net force was 0. So the system, surroundings, and the initial conditions. The system was the expo marker, which was that 0.01 kilograms. The surroundings was the table that we rolled it on, as well as air. The initial conditions, which we got from Tracker using the videos, the initial position was around negative 0.01500, which I know is not exactly 00. Like it would be in a perfect model, but I still used this initial position when I updated the things in GlowScript, and so it doesn't really make a difference. It's still showing the same like predicted data. Using the initial position, we were able to get the initial velocity of 0.58, and since we set the net force to 0, we're not going to really take into account how the friction of the table or air resistance is going to like affect the system at all. So this was our setup. We put a 1 meter stick down on the table, and then we just rolled the expo marker along the table, and we just tracked it frame by frame, and each frame was 0.033 frames per second. And yeah, this was just the setup. And so this was the data that we got from Tracker. We again analyzed the video frame by frame and measured the ball's position over the time. And so this is kind of that graph showing the position versus time. And so you can see that the data is nearly a straight line, which is what we would expect if the ball was moving at a constant velocity. And then in GlowScript, we updated some of the equations. I updated the position to give that same starting position that was in Tracker, as well as the initial velocity, and then the size of each time step was 0.033, and then FNet was 0, and then using the momentum principle, we update the velocity and the position within Tracker so that it can kind of give us that predicted stuff that we're looking for. And this is the graph that we got. The predicted graph is the blue line, which you can see is like exactly linear just because that's what it should be. And so the actual was a little bit off, but that's mainly because we set the net force to 0, and so we didn't actually take into account any like real world effects like that friction or the rolling resistance or like any of minor errors within the video analysis. And so that's kind of what the GlowScript model is not taking into account. And so that's kind of what explains this little difference over here. But for the most part, at the beginning, it definitely stays pretty close until kind of it's off the end. And so this kind of highlights the importance of identifying assumptions. Since I assumed no net force, there were small opposing forces slowing the expo marker. So yeah, so for the end reflection questions, the what if when you analyzed your video in Tracker you made a choice of the orientation of the axis. And so if we were to flip the axis to make positive x, negative x, the numerical positions of the numerical values of the positions would all be reflected across the origin, and the slope of the line in the graph would change sign. So instead of a positive velocity, the velocity would be a negative. That said, the magnitude of the velocity would still remain the same, and like the physics and everything doesn't change. It's just simply the sign and how the graph looks. The ball or the expo marker is still moving at a constant speed in a straight line. It's just a matter of kind of how the axis orientation is chosen. So What does this mean? In the GlowScript model, I set the net force equal to 0, which gave the results that matched the tracker data well, but that doesn't mean that there were actually no forces acting. There really were several forces. There was gravity pulling down, the normal force from the table pushing up, and the small frictional forces opposing the motion. The downward and upward forces cancel each other out. That's why there was no vertical force, and the friction was small enough to ignore. So we can't say exactly how many forces were acting from just the data, but the vector sum of all of these forces in the horizontal direction was close enough to 0 that we were able to assume why the ball moved nearly at a constant velocity. So yeah, thank you very much.